Okay, so welcome back to CIS 174. We're going to continue through our process of going through more chapters. As I said in prior recordings, you are more than welcome to read ahead and do the labs ahead. You do not have to go at the speed that I'm going. This is supposed to be self-paced anyway, so you are free to roam as you please. This lecture will cover chapters 3 and 4, with chapter 3 being small in comparison to chapter 4. So let's just jump right in. Again, as always, feel free to ask any questions in the chat. I am watching all chats just in case there are any questions. We are in chapter 3, and we'll be doing that, and chapter 4, creating virtual machines and introducing vCenter. A lot of the stuff that's covered here you've already seen in the micro course. So this can be some review. You can create virtual machines in several different ways. You can either follow the wizard, you can deploy one from an existing template or a clone, or import one either through a virtual appliance, through a VApp, an OVF, or an OVA file. Creating a virtual machine in VMware is pretty simple. It's actually simpler to create a virtual machine in VMware than it is in AWS. For whatever reason, AWS is really complicated and annoying and has way too many options that you need just to create a simple VM. But VMware has it right in a very simple format to spin up a VM. A difference being you need to provide a operating system disk, like an ISO file, to install an operating system if you're starting brand new, whereas anything in the cloud is already installed, and you're basically just creating from a template from the cloud. So you select the name, you select what kind of OS it's going to be, what family, and a specific version so that it installs the proper hardware with it. You can define the hardware to say specifically how many CPUs, specifically how much memory, hard disk, so on and so forth. Like I said, if you're installing a VM from the start, you will need to provide a operating system install disk because the virtual machines are blank. It's like getting a brand new computer that doesn't have anything installed. You have to start from the beginning and install the guest OS as you would on any physical system. It is a little faster, although like with Windows, it's always slow. So you can expect to at least spend 30 minutes installing a Windows OS and probably like 15 or so installing a Linux. OVF template is faster. You can create OVF templates yourself. If you create a virtual machine, then you can export it as an OVF or an OVA file, and those can be imported anywhere else. And they'll carry with them all the settings that you made. Like if you created a virtual machine with 2 NIC cards, it would come out with 2 NIC cards. If you had it with 4 CPU, it would keep the 4 CPUs as it goes from one machine to another. OVF is basically a zip file. OVF and OVA formats are both pretty simple. What I like about it is that it's all nicely packaged. VMware Tools is essential. It is the suite of utilities that has the drivers you need in order to make that operating system within the virtual machine sing. I highly suggest installing the VMware Tools whenever you're working with any VMware virtual machine. At the time of this writing, the latest version was 10.1. I'm sure it's a newer version. You always want to maintain the latest version of that VMware Tools installed on your VMs. Interestingly enough, whenever you do update like the ESXi or vCenter, and VMware Tools gets updated, you will get a little pop-up within the VM asking you to update, which I think is pretty neat. It is essentially an ISO file that gets loaded. So there are three, one for Windows, one for older Windows, and one for Linux. There are others for Solaris, Mac OS, and all the others that you would have to download yourself, but they do exist. If you have any issues with the 64-bit OS, make sure, number one, that OS can run within VMware, and make sure that you set up everything properly for a VMware, for a 64-bit. Because this is VMware, it can emulate anything. It can emulate an 8-bit, a 16-bit, a 32-bit, and 64-bit operating system. It's pretty flexible. But at the same time, you got to make sure that you have the right setup for the operating system you want to run within that virtual machine. If there are other hanging issues, you would go throughout any usual typical troubleshooting phase of is this disk, is it corrupted? Is the correct operating system selected? Because if you select a Linux as the OS that will run, but you're installing Windows, the hardware is going to be different. The configuration will be weird. Things will just go south. Make sure that the hardware itself is working fine. And then you have a lab based on that. Like I said, very short chapter. Mostly because there's not much to creating or deploying a virtual machine in VMware, which is actually a good thing. Chapter 4 is a little longer. So let me take a quick sip. This one covers vCenter Server. Essentially, this is the mastermind that can control various EXSI servers at once and orchestrate work all together. For a lot of the course, we're going to spend time working in vCenter because there's a lot of options and a lot of ways that you can control servers and virtual machines and high availability and all that stuff through vCenter. This is the big monster, cut up into 7 pieces as introduction. Nobody wants to manage each server individually. It is much easier to manage them all from one central place. That is vCenter. You log on to vCenter, and from there, you can control, manage, secure, administer, do everything you need to all the systems. It is now running fully on Linux. It used to be that you could run it both on Windows or Linux. It actually now runs as an appliance. So it's an OVF file that you import into your EXXI server, and that becomes the thing that controls everything. So we have various systems, and they have different operating systems running within them. vCenter has its own single sign-on system. It has its own embedded database. It has its own management and authorization. It's all in one, built in to control all your systems with a GUI, a web GUI, that's pretty easy to manage once you understand how to work it. So vCenter has all these items. You have the vCenter server itself. You have the web client. It has an update manager. It has an update deploy or auto deploy, a dump collector, and the client. All these things make up vCenter itself, and all of them show up in that one appliance that you add on to your infrastructure. Like I said, this thing will see everything that's happening everywhere. So you'll be able to see the health of your system infrastructure wide. So you'll be able to know when one system's hard drive is dying, or you'll be able to know when one system or two systems are unhealthy and why. It is not like Windows where it just says there's an error and that's it. It actually gives you much more details that you can work with. There's a lot of communication that happens with vCenter Server, which is why it's normally a best practice to have vCenter and its communication happen on a different physical switch or a different VLAN from everything else. You put your management network separate from your regular virtual machine traffic, because you want, I mean, this is more essential than anything else. With if vCenter fails to connect and work with the hosts, then you can't control, you can't manage. So it is generally ideal to either put it in its own VLAN or put it in its own physical switch. Also prevents anybody from logging on who doesn't have the proper rights to log in to vCenter by putting it on a different VLAN or different switch. And like I said, the appliance itself is a prepackaged Linux-based that has all the items I mentioned earlier, containing things like Photon, the platform service controller, its own database, and its group of services. It's all built in. You don't have to install the OS and install everything else. It's all prepackaged for you, making life that much easier. The Postgres database that comes with it can handle 2,000 hosts. That's 2,000 physical hosts. It can handle 35,000 virtual machines, 25,000 of those powered on. And this is with 6.5. 7 should be able to handle even more. So that one database that's already built in can handle quite a lot. And when you play with it, you'll see that it doesn't actually use up a lot of power, but it is definitely a very powerful appliance. Here's kind of the comparison with Windows, but like I said, it's pretty much a moot point to even talk about vCenter running on Windows because that's not supported anymore. The platform service controller, which was mentioned earlier, this is the thing that handles things like single sign-on, your license, any lookup service, any certificates, and directories. This can be installed on the same system as vCenter or installed differently or on a different box. But this can be the system that handles your, essentially your single sign-on. You have your accounts, one place to manage them all. vCenter's single sign-on can work with other systems like Kerberos. So if you wanted to use your domain controller, you can connect the two together and just use the your domain controller's credentials to log in. You can also just use the single sign-on that comes with VMware to create your own domain that's separate if you don't want people from your current domain to have access into vCenter. There is enhanced link mode, which can connect up to 15 vCenters together. Now, this is talking huge. This is if you have a couple of data centers scattered throughout the nation or scattered throughout the world and you want to manage them all together. That's where this comes into play. Your server deployment options vary, but it is easiest by using the appliance that has everything all together. You could split it. That's also a possibility, to split the roles apart by different vCenters. But it's really best to just use the appliance. The platform service provider, or the embedded platform services controller, handles its own standalone deployment. This is kind of the thing that handles things like it can handle any name resolution issues. So in case DNS dies for whatever reason, it still continues. It's a good backup. They can be linked together, of course, because most of VMware stuff can be linked together, like Legos. You can deploy a load balancer. This could be another virtual machine, or it could be a server who load balances all the information that's coming out of vCenters and putting them all together. This ensures high availability. This ensures that the infrastructure that is managing everything else stays up and running no matter what. There is an API for those who want to use APIs to deploy rather than using the GUI. This is definitely useful when we're working with a very big infrastructure, and clicking around is just going to take forever, but we can script things to get done, like deploying new VMs on the fly or creating backups and doing management tasks. That is all possible through the API. I mentioned high availability. This keeps your infrastructure running, basically making all systems into hot sites. So in case a VM dies because the hardware died, the VM continues to live on another physical system without skipping a beat. That is part of what a vCenter does in ensuring that systems are always running. Deploying this is easy because it's all in one appliance. You do need to have a couple items in place. For example, you need to have the fully qualified domain name or the static IP that it's going to use. You need to make sure that all the clocks are synchronized, because all the systems will be working as one under vCenter, and time needs to be the same everywhere. I suggest using UTC because that doesn't change. There is a native Gui installer, but again, for Windows, this is a total moot point. You can install, you can upgrade as they update the vCenter. You can do that as well. This is what you would normally see: is you just deploy the OVF by uploading it into your first ESXi server, and then you would configure it. The two-stage deployment, the first would be doing the simple things of accepting the EULA, choosing the type, getting it up there, selecting the size. Once it's up there, then you join the single sign-on. You join the customer experience program if you want. If you choose to go embedded, you see the things that you can do. If you choose platform service controller, the things you can do. The vCenter, the things you can do. You can custom the ports that you'll be using to vCenter. This can be a good idea if your vCenter is facing the internet and you don't want the standard ports that people scan for it to come up. Since it is using HTTP and HTTPS, your defaults are 80 and 443. If you want to change it, you can do that during the configuration phase. Once it's up, which again, it won't take a long time to be up, you can proceed to the web client by going to its website. You will more than likely be presented with a certificate warning because it installs HTTPS, a self-signed certificate. So you'll need to install a new certificate from like Let's Encrypt. Then you won't have a problem anymore from your browser. Once you are in, you do have a 60-day evaluation period that you can change when you have a license. Then you can go over to the Configure tab and start seeing all the settings and start making changes as necessary. These are the things that you'll see as you do your lab in NetLab. Your inventory is your basic place where you see your servers, your pools, your VMs, all that info. As always, you would log in to the web client. Under menu home, you'll see the inventory list. And there you'll be able to see the vCenter and any physical hosts. If they're all connected into a single data center, you'll see them as a data center, and then you'll see the hosts and the VMs that exist within. It is pretty intuitive once you know what you're looking at. Like in the first option, you'll see the host and clusters. In the second one, you'll see any virtual machines and their templates. In the third, you'll see all storage. And the fourth, you'll see all networking. Ta-da. So for example, you can see in this data store how much space is being used up, how much you have free. In networking, you see the switches that exist, not the physical switches, all the distributed and static switches. The inventory gives you a lot of good information. Besides the physical information, the overall usage of the system. Filters exist, so if you need to hunt for a specific item, it's there for your convenience. It is very easy to drag objects from one item to another within the inventory list. You can see all tasks that you need to do and check them off as you do them. So if it's time to do a backup and you've set that up as a task, that will show up. A single vCenter server is possible to control a number of data centers. Like I showed in the earlier slide, it can hold up to 2,000 unique physical hosts. So it is possible by using one vCenter server to control data centers throughout the internet, as long as they are all interconnected to each other. You can create data centers, and within each data center, you can have its own database, its own folders within, its own hosts, and all can be managed from one vCenter server, making this quite a prime target. You can add data centers very easily by just right-clicking in vCenter and saying either new data center, or if you wanted to add a new object like a new host or a new cluster, you can do that easily by right-clicking. A lot of these options are just right there in the GUI. In this case, you can add an ESXi host just by right-clicking on the data center, selecting a new host, providing its name or its IP address, and adding it into the data center. You can increase security by implementing lockdown mode. That means that anybody who goes up to the physical machine will not be able to log in and make any changes. You can enable and disable things like SSH access, so nobody can have physical access to the system, they'll have to go through vCenter in order to configure and manage the system. The strict lockdown mode employs the most stringent rules that will really prevent no one from accessing the box unless you are running from vCenter. Of course, you can create custom tags. This is useful if you have a lot of systems and you need to manage them in various areas and it's all over the place. You know, this can add some sanity to your life by giving tags to objects so that when you need to search for those specific objects, it's a piece of cake. Because this is a pretty powerful system, we need to talk about permissions. You should not just give free reign to anybody and everybody. You should be really specific as to who has access to what, because as you can see, this vCenter appliance is pretty powerful and can do quite damage in the wrong hands. So the important concepts are the permissions, the privilege, the roles, the objects, and the users. To add a permission, it is pretty simple. You can right-click on an inventory object. You can add a permission, select the user or the group, select the role, and then hit OK. You have some default roles that exist. You can add your own roles and have specific things that those roles can do. Highly suggest that you implement these roles in order to ensure that your systems are secure, because like I said, this is a pretty powerful tool. All your objects are the entities on which actions are performed. So that can be a data center, a folder, a resource pool, a cluster, a host, a data store, a network, or a virtual machine. And they all have permissions. You can see the default permissions that exist and change them accordingly. The global permissions affect the global root object, which is basically way up at the top. Think of the tree. That's at the reverse, at the top of the food chain. Anything that you apply to the global root will affect everybody. So again, be very careful as to what everybody can do. You can see what user has what role, what user is part of what group. As always, it is best practice to minimize the number of administrators and instead create proper roles that follow the least privilege principle to prevent any accidental takeover or mistakes that could be catastrophic to your infrastructure. Here's just a scenario. We have our vCenter. In it, we have a data center called training with 2 folders. At the data center level, Greg can only read, but on this production 032 virtual machine, Greg has administrator rights. So he can read, he can see what's happening on these other systems. He just can't manage them. But the only one that he has control for is this specific system. In this case, we have the same data center and 2 users, or 3 actually, in 2 groups. There is a custom role that can turn on virtual machines, and there's another custom role that can take snapshots. In this case, Greg can both turn on a virtual machine and take a snapshot, but Susan can only turn on a machine and Carla can only take a snapshot. Again, this is by the least privilege principle of users should only be able to do what they need and nothing else. In a reverse, another way, group 1 is administrator. So Greg and Susan can do anything and everything. And in group 2, read only, Greg and Carla can only read what's happening on this specific VM. Another way, we have 2 groups and a specific user. Anything that's explicit for a user takes precedence over the group. So keep that in mind. Anything that is explicit for a user will take precedence over all groups. So just because Greg is part of group 1 and group 2, if he's set to read only, that will take precedence over the others. Creating a role is pretty easy. And it can be applied to many things. Like in data store, who can allocate space, and network, who can assign a network, so on and so forth. You'll have another lab to work on that. Backing up and restoring, essential tasks, because again, we're working with critical infrastructure here. There is a management at port 5480 on your appliance. You'll see a different set of things that you can do. There are native backup systems that you can use, which is great. You don't have to depend on a third-party tool to back things up and risk things not working properly. It has quite the number of protocols that it supports that are secure. And you could restore directly to an ISO image if need be. You can do either file-based backup or image-based backup, using different ways to back up your appliance. You can set this on a schedule, and the schedule will work, or one schedule works at a time, which again is good because we're messing with critical infrastructure that runs everything else. We can use the Gui installer in an appliance to bring back any failed system. The OVA file does have a way to restore any file-based backup should the need be. And your backup can be scheduled, and it can be through a variety of protocols. It can be encrypted. You can define the retention policy and how often for it to back up. Any fails in the backups will be reported to you as an alarm. Just like everything else, it's GUI based and pretty easy to set up a backup schedule. VMware does do a good job of keeping things easy to find. Once it's set up, you can see the schedule and make any changes or disable as needed. We can monitor what's happening all across our systems. I really like this. Being able to see all the events that are happening in one place, sorted by their ID, the file path, any source, any name, dates, and times. The system logs are also reachable, so you don't have to try to log in to the Linux OS that's underneath the appliance. You can get to it right from the vSphere client. Your log levels are here. If you have it to none, it's not going to log anything. If it's errors only, it'll only do that. Warning will do errors and warnings. Yeah, the lower you go, the more information you will log in. A word of caution is if it runs out of space in the appliance, vSphere crashes. So if you are turning on logging, make sure that either you are passing those logs elsewhere for further retention or you're removing them on a regular basis so that you don't run out of space. So within the vCenter server settings, you can define what level of logging do you want based off of this chart. You can forward that log information, which again, I think would be a better idea, is to forward the logs into a remote syslog server to then manage, so something like Splunk. The vCenter server has a database health check that runs every 15 minutes. If space reaches 80% use, it's going to alarm. When you reach anything 95 and up, the system starts to shut down and tells you you need to get rid of stuff. You can manage all the services within that same web client. So again, one central place to do everything. And you'll find it in administration, system config, under services. You have built-in monitoring interfaces. You can see the histogram of CPU usage and memory, along with all the disks that are being used. This is a great place to monitor the health of all your services, being able to restart whatever is necessary to ensure life is working, and quickly troubleshoot. It has alerts and alarms to tell you if a service fails. For the most part, it also provides links on how to fix it, the issue. Monthly patches do come out from VMware, similar to Microsoft's Patch Tuesday, that you can deliver to your system. These should be installed and you should stay up to date when the next update arrives. Any questions on, I know I went through a lot. Any questions? Okay. So like I said at the beginning, I went through these two chapters. So here are the corresponding NetLab labs that you'll do. If you feel like I'm going too slow and you want to jump ahead and do more chapters, feel free to do so. There's nothing saying you have to go at the speed that I'm going. If there are no questions, I do not see any reason to hold you hostage any longer. But if you do come up with any questions, feel free to ask away in Discord.